Alright, the moment everybody's been waiting for. How the heck does this actually look? Okay, so the paper you see in front of you is one of my standards. So where did I get these? Well, when the first section, or the first, draft, there we go, of standards that I made, I took from the curriculum that I was given at my school and separated the topics out according to kind of how I thought they would be grouped. Think of these as units, if you will. And it was typically how everybody else had organized the chapters before me. Then when I started looking a little bit more in depth at standards and assessment for learning, standards-based grading, all that nonsense, I decided I didn't like how the standards were organized. So I went back and I regrouped them a little bit. Again, still not anything terribly out of the ordinary. And the first set of standards that I came up with was just a list. It did not look like this in this rubric setup. Instead, it was more of your stereotypical bullet points. But that wasn't something that I could use, because what I wanted was a piece of paper that could serve both as my standard for my course, but also as the rubric for my test. I didn't want to have to make rubrics for every test that I was running into. And that list, it was just something for me to have so that when somebody said, "What are your standards?" I could hand them this list. But I wasn't using it. So even though I put the learning targets up, put the learning objectives up, all off of that sheet, it still wasn't making its way into my assessments and into my classroom the way it should have. So the next thing I created was a rubric similar to this, except instead of having larger columns like this, I had kind of more of what you would think of your stereotypical rubric, where it's, 4 points, 3 points, 2 points, 1 point, and then it's a grid across of how students would do, and I would highlight according to what the student did or did not do right or wrong. Like this one would say uses periodic table, this one would say recognizes periodic table, this one would say define. That Bloom's taxonomy word game was what I did, and I would highlight where in that continuum the student fell, and from those highlighted squares would come up with a grade for that test. But I didn't like that because it was too subjective. And also it was really hard for me to come up with a Bloom's word for each one of these concepts all the way across the different levels. It was just too much. I didn't like it. I wasn't using it, which meant it was largely useless. Not to mention that purely subjective nature of looking at highlighted squares and coming up with a grade didn't really appeal to me. I am a science major, so I like numbers, I like data, and that was too subjective for my taste. So the next set of standards that I came up with looked like this, where instead of having the grid, I have 4 columns. I should back up. Another thing I discovered when I was working on my first set of standards was the realization that the way I had written the standards allowed for students to get all of the easy questions right and still get an A. And I wasn't okay with that. They could do all of the molar conversions but couldn't do stoic and still somehow got an A. So a rubric like this allows me to weight the harder concepts with greater points, if you will, quote unquote. I hate that word, but greater intensity. We'll go with that. Then I ran into the problem of the next generation science standards. Those just came out, and so all of these lists here, or these references, actually directly reference the next generation science standards. These are written according to those. There are a few things in here that are not in the next gen standards because I didn't feel comfortable taking them out just yet while everybody was still kind of learning what to do with these stupid things. So, this setup is a little bit different than my original setup because originally, as I said, the concepts were grouped according to difficulty level. So simple things like protons, electrons, and neutrons would be over here in the introductory column, and harder things like utilizing bond type would be over here in the higher levels. Since the next generation science standards focus on application, I made those, so these are almost verbatim from the next gen. And those are the application standards. So if you want an A, you have to be able to apply the concepts. I don't care how many times you can do a Lewis dot structure and tell me what it is. If you can't apply it in some sort of outside the box thinking, it's not going to help. So this year I have done that a little bit. You'll see how, for example, types of reactions Can you see that? No, you can't. There we go. Types of reactions is over here under intermediate concepts, where I don't have it under these introductory concepts, because I thought that was a little more difficult than just reciting atomic trends. But anyway, so this is my standard. This is my first chapter, if you will. So what I will do on the first day of class, and this is actually something new. If you're not someone who tries new things on a regular basis, I think you should. I am notorious for experimenting with new things, and if it doesn't work, try again. The worst case scenario, it doesn't work. Or that's my philosophy. So the new thing I will do this year is, first day of class, I will put these up on the board, or something like these. These are largely application questions, stemming from that first column in the on my rubric. And I will put these up as sort of a pretest of sorts, and students will write down the answers as best they can, and I will collect them, and I will look at them. Got formative assessments. I just want to know, what can you do? Same as a pretest anywhere else. And from there, we'll start the lectures, just like any other class, just like any other subject under any other system. I will start by teaching them what is an atom, protons, electrons, and neutrons. We'll talk about it. Maybe we'll draw some pictures. Can you see? Yes, okay. I apologize, I'm not exactly sure where the screen is on my camera. We'll do lots of practice. I said I love doing group practices. I'll put 4 or 5 problems on the board and then tell the students to have at it. And they'll work together. They'll work independently if they want to. Ask me over for help. And then at the end of class, I'll put a problem on the board for them to do on a sticky note. Diagnostic. How well do you get this when you are on your own? If everybody starts showing, 4s and they're able to apply this concept, not just answer the straightforward questions, time to move on. And we'll move on from there, and so on and so forth. Just as your typical classroom would. Not really anything different there. Lots of pop quizzes as we go, lots of formative assessments. Then when test time rolls around, I generally organize my tests like this, in the sense that the test will get more difficult as it goes. The introductory section will have just definitions, basic ideas. The basic section will have straightforward questions. The intermediate section will have the concepts in discrete questions. Granted, they will be more difficult than those in the basic section for obvious reasons. And then the top section will be the advanced section. These will be your application questions. A lot of times the tests are set up such that the students do not have to do all of the questions. I tell them to start at the grade they want and work backwards. Because odds are, if you do this in a problem, use the periodic table to predict properties, you are going to tell me, by definition, what the properties are. You are going to tell me how they work. You are going to tell me how you came up with these properties. All of those lower levels are found in that advanced question. So a student may not do the entire test. They may not have to. They only need to show me knowledge of these concepts. I even tell students, again, this is my room, I realize college doesn't do this, but this is what I do. If they're not sure what the heck a question says, but they know that this is the standard 1 test, they can just write me definitions on the back of the page, or make up an example. Granted, that is not any of these, because they could not do the question that I asked, but it would be better than leaving it blank. Again, it demonstrates knowledge, which is the overall goal here. It's the reason I've made all these changes, do all this wonky stuff, is because I want the student to show me what they know, not what they don't know. By leaving it blank, you're just telling me what you don't know. I don't care. I want to know what you do know. So, how does this thing actually give me a test grade? And this is where the number crunching comes in, courtesy of the wonderful math teacher here at Valley Park that came up with it. And I like it because it gives me a mathematical way to come up with a score, and leaves me feeling less subjective. Because, I mean, let's be honest. If you grade a test and you're in a bad mood, odds are you're going to score the test harsher. We are human as teachers. We can't help it. Anyway, so let's say this particular student got all the way to the advanced section. So in each of these blanks, I will put a 4, 3, 2, 1 score. How well did you do on that standard? Because the kid gets this back. This is stapled to the front of their test. Let's see what you can see. There we go. So let's say They're not really good with periodic table. I'll give them a 2 on that. Not doing that great. Got a basic understanding of this application problem. They did it, but it's just basic. I mean, they gave me definitions in the right places, but it's just not that great. Let's say we did great, awesome, spectacular. 4 on, I hope you can see those numbers, on predicting based on chemical reactions. And let's say for some reason I just didn't have a question on that on the test, so I would mark it with a slash. This column is out of 4 points. I hate that word. So 2 plus 4 is 6. There were only 2 questions, so divided by 2, so they got 3 out of 4 possible points in this column. I know I'm using points, and I know I said repeatedly that I hate them, but I could not come up with a better way to numerically come up with a score because I hated the subjective that much. Alright, so let's see. They're just not that good with trends. They're great with these. Let's say this needed a little work. And I'm assigning these scores based on what those numbers mean. 4 is awesome, spectacular, beautiful, absolutely flawless. 3 is maybe you made a stupid mistake. 2 is you got the right idea, but totally the wrong direction. And a 1 is you gave me something, but that's about it. So let's see. This was not in this test. So I would add all these up, divide by however many I got. Let's see what that is. How am I doing on time here? Woo, I gotta hurry. Should have already had these calculated. I apologize. 4 plus 4 plus 3 plus 2, 4, 6, 8, 10, plus 5, 6, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, that gives me a 2.45, but this column is only out of 3 points. So what I'll do is I'll take that 2.45 and I'll divide it by 4 to get a percentage. And then I will multiply that by 3. So they got 1.84 out of those 3 possible points. I know it seems like a lot of math, but that's what you do really when you're grading tests, is you do math. For argument's sake, let's say they get all of this and all of that, just so I can show you the final piece. 4 plus 3 plus 2 plus 1 is 10. So this whole thing is out of 10. So what I'm going to do is I'm going to add all of my numbers up. I'm going to divide by 10. That's going to give me a percentage. Add all these numbers up. Divide by 10. That will give me a percentage. Multiply that by 4 because my system is out of 4. And that gives me a 3.14 as the final score on this standard for this test. That's just above a 3. And frankly, I would agree with that assessment. 3 is an intermediate application. They did really awesome here. Can you see that? They did really awesome here, but they did really mediocre here. So they're a little bit higher than a 3, but they're just not quite there yet. So it shows that they need a little more work, but this rubric also shows them where they need a little more work. Me and my colleagues are still tinkering with these numbers as far as if this is actually the most accurate means to come up with a score on this kind of rubric, and it is a work in progress. So if you have a better suggestion, please by all means make it, but right now I am running out of time. So I thank you very much for watching this video. I hope it has given you some food for thought, or at least a direction in which to start with standards-based grading. If you have any questions, let me know in the comments, or find me on Twitter. If you've got more stuff you want me to talk about or discuss, please let me know. As I said, this is my passion. So best of luck in exploring. Try new things. You're awesome just for trying. So have a great day.